With a great pleasure, because this is one of the best speakers out there in the games industry, and I'm daring to say this. It's my honor to welcome to stage Ari from Epic Games.
Thank you so much.
Ready, set, let's go! Ready, set, let's go! On your mark, get set. We're gonna take it to the red.
This video is actually so long.
It's time to get it started.
3 whole minutes, and it's constantly looping in the hall over there. So, hi everyone. Thank you so much for waking up so early after hopefully not partying too much yesterday. I hope you're not hungover. Yes, it's always nice to be on the second day of the conference, the first talk, and everyone's like, and I'm like, don't worry, this is very technical. Also, sorry about that. This is going to get a bit technical at parts, but I'm also going to try to keep it kind of fun. I'm going to try to make it generic at parts so that even if you don't kind of like do graphics or programming, you'll at least be able to have enough takeaways that you can bring this to your team. One thing that I want to do, though, because I started doing this and I really like it, is that I like to take a selfie with all of us. And then I'll share it on my Twitter. And if you don't want to be on the internet, you can just go like this. But it would be great if you can go like this and also wave to make it look a little bit more alive. So I was thinking we could all say hi from Helsinki, because that's where we are. So I would count down 3, 2, 1, and then we all go, hi from Helsinki. Let's practice it. So 3, 2, 1. Hi from Helsinki. Okay. But this is our morning voice. I want to hear like party voices, like hi from Helsinki. Okay, let's try it once more. 3, 2, 1. Hi from Helsinki. Much better. That's the energy I want. And then I'll put it on my Twitter, Flussary, and maybe Natasha will retweet it. We'll see. So let me see. Selfie mode. Let me come a little closer so it looks like we're way more than we actually are. I'll come down here. Okay. Are you ready? 3, 2, 1. Thank you so much. Now that was a great start to the day. So you might have noticed I have some stuff here. I'll explain that in a while. So this presentation is called Maximizing Your Game's Performance in Unreal Engine. I've been doing a little bit of road tour with this talk, and actually next week is where I'm going to have the grand presentation at Unreal Fest, so you're actually getting a sneak peek. You're also getting a practice run, so I'm practicing on you. So if you see this online at Unreal Fest, I'm going to be reusing all the jokes. So sorry about that. Not sorry. And I have a bunch of things in this presentation that I just really wanted to kind of like teach people about. But there's this one thing in this presentation that I like it so much, I put it right at the start. I've been looking forward to showing this thing to everyone. It's me! Hello, everyone. So I am Ari Arnbjörnsson. I'm an Unreal Engine evangelist at Epic Games. I often get the question, what does an evangelist do? It's a really weird name for like what I do. Some people would call it developer relations, but I do more than that. I go and speak at conferences. So I guess to summarize it would be, I try to drive up adoption of Unreal Engine and support the studios that are already using it. And then you kind of fill in the blanks. How do I do that? Well, I go to conferences and I speak about Unreal Engine, about how you can make better games. I talk to studios. I'm basically a first point of contact to Epic Games. So if you have questions about Unreal Engine, the store, mega grants, whatever, you can always hit me up. And yes, you might have noticed my first name sounds, because I am Icelandic, so my first name sounds Finnish, and my last name sounds a bit Swedish. So often in Finland, people go like, Ari, suomalaisen Arnbjörnsson, Finnsweet, terve, mitä kuuluu? No, just English, please. I am a game programmer. I've been 15 years in game dev. I've actually been programming for 20 years. And every time I get stuck with my own code tripping me up, doing something and making me spend hours on it, I get one gray hair. A common question I get is my hair color real? It is. This is genetic. Me and my father and all my brothers, we all look like this. And we also have quite a bit of spring in our step. So when you see like 4 white heads going like this, you can go, oh, those are Arnbjörnssons. So that's us. And I put my personal domain there, ari.games, because all of my presentations, most of these are Unreal related. Often I want to share it with people. I want to go, hey, go check out my presentations. So I put them all on there. I also put my Unreal Engine notes there. Usually, because Unreal Engine, it's a vast software, and every time you learn something new, you're probably not going to be like remembering all of this. So I always recommend just make your own notes, like put in a Google Doc or Notion or Notepad even, or something like that. And I did that, and then I realized, you know what, actually I could just make this public and clean it up a little bit. So I did that. All of my Unreal Engine notes are there. If you're getting started with Unreal, I really recommend you check this out. There's also a presentation there called Lessons Learned from a Year of Unreal Engine 4 AAA Development. And that was my first year of making Returnal before it was announced. And basically, I started using Unreal, and I was like, that's a lot of stuff no one tells you. I need to tell other people about it. So check it out. Also, this domain cost me about the same as a Netflix subscription per month. And the only reason I have this domain is so I can tell you to go check it out. So please don't make that money be in vain. And yeah, this is my contact info. So for this presentation, 3 topics that I want to talk about. We have profiling in general, and this is what everyone can like get something out of. Then I talk a bit about profiling with Unreal Engine. If you are using other engines, this is where you're going to go a little bit like, yawn. And then lastly, I'm going to go into practical examples. This is the meat of the presentation. This is what I feel other presentations don't do that much. It's like showing you actually wrong things to do and how to find them and how to fix them. And of course, because that's the most fun part, I left them till last. Yes. And then I brought some stuff here. I brought some swag. So these are Epic Games keychains, and then if you squeeze the sides, there's a little cloth there to clean your glasses. Or if you don't wear glasses, clean someone else's glasses. You can just go like, they'll love that. And I have one pack of one T-shirt also, because one question is going to be like a big one, but whoever guesses it gets this one. If no one guesses it, I'm taking this back home. So yeah, you better get it. And I'm going to be asking questions, yes, throughout the presentation. Well, not that many. Like, for example, profiling with Unreal Engine, there's not going to be any questions there. And whenever I ask a question, if someone gets it, I'll just throw you some swag. I'll try not to throw it too hard. If you're in the back, I'm sorry, it might hit someone in the face. When I ask questions, don't raise your hand, just yell it out. I'm going to go like, what's this? And you just go like, ugh! And then I'll go like, yes! And I think that's a good format, so let's go with that. I think we can already start with a pop quiz. What is this? That's good, your reaction time. We actually take less percentage than that. We only take 12% on our store. It's okay. This is, if you haven't been doing that much profiling, this might look a little bit alien, but there's actually another number there also to give a little bit of hint. Does anyone recognize this? Well, I'll tell you. These are milliseconds. These are the amount of milliseconds in one frame, for 60 frames per second and for 30 frames per second. So for CPU and GPU, you usually have, for 60 frames, you have 16.66 milliseconds, and then for 30 frames per second, you have double that. Although nowadays, gamers are getting more, well, depending. If you're doing a mobile game, you can get away with 30, but for console games, they usually want 60, unless you're going for something looking really, really good, but next gen has always been about 60 frames per second. And those milliseconds, you should basically treat this as a budget, treat it like money. So some features, they look great, but they are expensive. So you have to decide when it's worth it. And to give you an example, it would be like, for example, if you have a wedding and you have 16,000 euros and one of you decides, hey, I want 5,000 to be spent on catering. And the other one goes, no, catering is going to be the thing of the wedding. I want it to be 10 out of the 16 MS or K that we have. And someone might go, that's really expensive. That's a lot of time / money. But if it looks good / if it's very tasty, it might be worth it to you. So for some games, some big chunks of that budget are going to be worth it, because if you wanted to go for the quickest, like the most fast frame, you would just not draw anything. 0. There you go. Great game though. So for consoles, you can actually spend close to all of your budget. You can get really close to that number of like how much computational time you're spending, because they're all cooled well. They all are about the same hardware, or not about, they're exactly the same hardware. However, for PCs, you cannot just use all of that. You need a little bit of leeway. Also, on PCs, the gamers, they are the users. They're going to be the ones that want to say, hey, you don't get to decide how you spend your budget. I want to decide how your game spends the budget. So I want shadows to be more, or I want them to be less detailed. They want to go into the settings and configure all of them. But the thing is, not all of them. So some users just want to be able to launch your game and start playing it. Maybe you'll have a little bit of auto detection or something like that. But the thing is, you need a little bit of breathing space. So don't go all in on like stuffing your frames too much. And then lastly, mobile. You might think, oh, I can get quite close to mobile for my target platform. And not really, because mobile phones don't really have a fan. On iOS, they're like technically more underpowered than Android, so you can actually use a lot of that. But the thing is, on Android, there was this kind of competition where all these different Android devices were like, we have a bigger GPU. No, we have a bigger GPU. We have a laptop GPU in our mobile phone. And it's like, there's no fan in this. How are you going to cool it down? So it will run your game super well, super fast, while it's cool, which is for like under a minute. And then it will start going on too hot, thermal throttling, because that's the only way it can not burn. And then it will run much slower than iOS devices, for example. So take that into account. Give your phone a little bit of breathing space, like take only 70% or something like that of the frame budget. I often get the question, when to optimize? When should I optimize? And if you've done any kind of software development or optimization, you will often hear this quote. It's like premature optimization. It's the root of all evil. Blah, 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 I say about that because it's a bit of an absolute statement. And I'm not a huge fan of absolute statements because we know who it is who only speaks in absolutes, right? Sure. Don't does that a lot. Who was that? Did you? Yes. Who else only speaks in absolutes? Come on. Hate leads to anger. Anger leads to suffering. It's the Sith. The Sith only speak in absolutes. So, but we're not going to speak in absolutes. So I'm not going to say like you shouldn't prematurely optimize at all. Like, sure, you shouldn't spend time on actually like prematurely optimizing, but you should still be performance conscious during development. So that means, for example, if you're coding, don't sacrifice code readability to do some micro optimizations before you even know if they're even affecting anything. So I know of programmers, we want to be challenged, we want to make sure we're doing everything super optimized. They'll start writing these weird for loops because it's like, it's a bit faster. And you're like, will you be able to measure the time and see a difference that isn't negligible? Usually the answer is no, you won't see any difference. So basically, don't do it in advance. So if you're, for example, are you already running on 60 frames per second on the target hardware? Like if you're aiming at, the next-gen consoles, then the answer is you don't optimize. But let's say that you are making something and you're like, well, I know I'm not supposed to prematurely optimize, but then when am I supposed to optimize? And then my answer is just when it shows up on the profiler. That's when you optimize it, not before. We were making Returnal and we were trying to figure out our budgets, but it's hard to figure out budgets on a console that hasn't released yet. So we were trying to say, like, should we have this vertex like limits or like how much? The thing is, like, we didn't hit those limits. We couldn't even find them. There were these usual things that slowed us down, but the other things that we were actually trying to limit, they never became an issue. So if you're doing games for next-gen consoles, I think it's great to just like make it as high fidelity as you want, and then when it starts slowing down, then you see what you should slow down. So then everything will look the best it can. So practical optimization is basically only optimize if you're not hitting your frame times. And usually you go for the lowest hanging fruit first. So you go for the biggest impact for the least effort. And that's what you use the profiler for. You see something that takes a lot of time on the profiler, and you're like, okay, well, this is actually quite easy to fix. It's just a single check mark. Do that. Wow, we got like a whole millisecond of the frame time. Those are the things you should go for first. And then you go for the next lowest hanging fruit first. That would take the least amount of effort to optimize. And then you do it a few more times, and now it's time to ship. That's how game development goes. You're not going to have time to do all these things you want to do. You have to go. You should go for the things that you have to go do first, not the ones that you want to. So also, don't blindly optimize. You should figure out the what, why, and how of optimizing games. Ari, what are the what, why, and how? Excellent question. I'm really glad you asked. So the what, why, and how. This is I came up with this. It's like, I don't know. This is kind of a no-brainer, but I thought, you know what? I'm just going to put it down so you at least have it. So first, when you're trying to optimize and profile, first you have to figure out what is slow. See what is causing the slowdown in a profiler. Because if it is time-consuming, it will show up. Only when you know what is slow is when you start asking the question, why is that thing slow? And once we know the why and the what, that's when we ask, how do we fix it? We ask, how do we fix it when you know what and why is slow? It sounds like a no-brainer, but some of the smartest people I know will not do it in this order because they will see something and they will immediately go, why is this slow? They just run the game. Why is the game slow? They don't even know what is slow. They just think like, why is the game slow in this part of the game? I'm going to just start fixing things I think this is affecting. So they'll go directly for the how do we fix it then without even knowing what. And can't blame them, but I always say like, no, figure out what first, you'll learn more. And sometimes you spend a lot of time fixing something and turns out it wasn't even that. And then you might break something because whenever you write code, there's always this like percentage chance of something breaking. What, why, and how. This was part one. Now we're going to go more Unreal Engine specific, talking about profiling in Unreal Engine. So we have these two programs that I usually recommend people use. That we have more ways of profiling in the editor, but these are the ones that give you great numbers on the what. So Unreal Insights, it's a program. It comes with Unreal Engine. It is not inside of it. It kind of stands next to it. So you just start it, but you can start it from the editor. You go to Tools and then run Unreal Insights. But because it's a standalone application, you can also just go into the binaries folder where the Unreal Editor is, and there's an executable there called unrealinsights.exe. And then once you have Unreal Insights running, you can just start your game, and it'll just automatically connect, and it'll just automatically start profiling, and super easy. So it'll automatically connect to it. But also there's this trace command parameter that you can start your game with, and you can use it to override which channels you are measuring. So by default, you're measuring CPU, frames, log, and bookmarks, and you can use -trace equals to override it. You can even put default in there to get all of these default channels, put comma, and then keep adding to it, GPU, memory, file, load time, something like that. And making a shortcut to your game with those parameters is handy. But if you're working in a team, you might even make a bat file, and then you don't even have to profile it on your own machine. You can use -trace host and then put IP to connect to another computer. And this is great if you're running this on a console or a mobile device, or even just on another computer, but the developer who is profiling wants to do it on their work machine. Then the other command I want to talk about, because Unreal Insights is great for CPU and memory and all that kind of stuff, but then GPU, that's always its own kind of monster, and we have a separate command for that also. It's called Profile GPU. And this you can launch both in the editor and in development build using Ctrl-Shift and comma. Or if you don't have a key, like for example, if you are running this on a development kit, for a console, and you don't have a keyboard connected to the console, but you can remote into it, then you can just give it the profile GPU console command. And what it does is that it will profile the current frame on the GPU side. And this command is profiled out in shipping build, so you can't use it there. So if you want to use it, you're just going to have to make a development build. And if you're running it in the editor, it will open up the GPU visualizer. It looks like this. If you're not running it in the editor, it will print the same information out to the console in package builds. So these were the first two sections, and now we'll go to what, in my opinion, is the most fun part, where we show you the practical examples. But before... So what I've done with the practical examples is that I use the Lyra starter game. So the Lyra starter game, it's a sample gameplay project that you can, it succeeds shooter game. Shooter game used to be our old, like, hey, here's how you can make a shooter game, like how Epic would do it. You can download it and use whatever you want out of it. You can even build your game on top of it. And what Lyra does is that it's our new version of shooter game. We're not working on shooter game anymore. Now everything is in Lyra. And it showcases a lot of Unreal Engine 5 features. Basically, if you want to know how am I supposed to use all these new features in Unreal Engine 5 to make a game, check out Lyra. We are working on getting it console certified, so you know that it's full of all best practices, how Epic Games would use our features. And I wouldn't be surprised. It's even encouraged that you can just download Lyra and just start modifying it until you have your new game. So you can download it from the marketplace. The team is really happy with it because it's such a great example of everything and how you should do it well. And I just took it and I was just like, you know what, I ruined it. I'm going to make an example of how not to do everything well, but how to do everything horrible. So I put some horrible performance issues into it, and now we're going to fix them together. The first curse that we're going to fix, the first issue. We have 4 of these that I made. 2 of them are GPU related, so for the graphics people. 1 of them is CPU related for gameplay or programmers. And then the last one is going to be a memory leak. Ooh. Low editor frame rate. Someone comes to me. Let's say I'm a lead programmer or something, hypothetically. Ari! And I'm like, what is it? The editor used to run at 60 frames per second, but now it runs only at 30 frames per second. It is so slow. I don't know what happened. It was working just fine yesterday. And I go like, okay, well, let's see if I can fix it. So my first thing that I'm going to do is that I am going to verify just what the frames per second are in Unreal Engine. Before I continue, how many people here are using Unreal Engine? 1, 2, 3, okay. So I'm wondering how many questions should I be asking, or should I just be telling you all the answers? I think I'll skip the questions. I'll just throw these out at the end to random people. I have actually so many that I think all of us might be able to get one. So low editor frame rate, yes. We have a way in Unreal Engine to see the frames per second. Does anyone want to guess how to? Does anyone know? Oh, okay. It's okay. So in Unreal Engine, there's this little hamburger icon there in the top left, and you can just click on it and say Show FPS. And you also have a keyboard shortcut, Control-Shift and H. What you can also do is you can use the little console command input there and write stat space FPS. And then when you do that, we'll get this. There's a number, FPS, and then also the milliseconds for how long each frame is taking. And usually when someone gives me a relative number like, Ari, the game is now we lost 2 frames per second. Let's say we lost 5 frames per second. It's 5 frames per second slower. This number means nothing to me because it depends on which computer it was running, and it depends on also what was the frame rate it was already running at. So if someone tells me we lost 5 frames per second, this can mean very different time spans depending on, for example, if we were already running at 30 frames per second and we lost 5 frames per second, that's like quite a good, as 1/6 of the whole entire budget. But if we're running at 120 frames per second and someone says we lost 5 frames per second, that's like negligible. It's like a margin of error. So usually it's better to say our frame times are 10 milliseconds slower. And I'm like, wow, that's a lot of time. I know exactly how long it is. It's the same, like no matter what the frame rate was before. But the thing is, I just showed you 2 different tools. I showed you how to profile a CPU problem and how to profile a GPU problem. So we need to figure out first, where is this time being spent? Is it being spent on the CPU side or the GPU side? And on Unreal Engine, we have another command to show more info on that. It's under Stat in the hamburger menu again, top left, Stat Engine Unit. The unit stats. So you can also, again, use the console command stat space unit, which is usually what more technically minded people will do because it's much faster to just write it down. And then we'll get also these numbers. So the first number is basically the same as the one here on top. It's the number that the entire frame takes. The entire frame is taking about 33 milliseconds. The game thread, otherwise known as the main thread on the CPU, that's taking about 5 milliseconds. That's actually very good. I would say we should be putting more stuff into the game to try to get closer to that 16 milliseconds. So like we have a more high fidelity game or like better AI or something like that. But now the draw thread is taking 30 milliseconds, and we know that 16 was the max we should be going for. So something is happening on the draw thread, and the GPU itself is looking at 33 milliseconds. So this is obviously a GPU problem, not CPU. So what I'm going to do is that I'm going to run the profile GPU command now. So I'm just going to write Ctrl-Shift and comma on my keyboard, and then this pops up. Sorry about how small it is, but I'll just walk you through it. At the top, we have the graphical representation of an entire frame, one frame. And then you can click the little white triangle to see like more what's happening. But what I like to do is I like to use the numbers down below. It's the same as above, but in a tree format. You can sort it by duration, and you'll see exactly how long everything takes. So here you can go into shadow dash, lights, like it's taking 5 milliseconds, lumen lighting taking 3. Okay, like some of these are really slow. So I'm going to just start going into shadow dash, render virtual shadow maps, BATS, raster patches. Okay, so there's some things they're called cursed point lights, and each of them is taking half a millisecond. And there's quite a few of them. Okay, that doesn't really look right. We have some rectangle lights that are taking like no time. And then we go into the lights themselves, direct lighting, unbatched lights, and then the cursed lights are there also, and they're taking like 1/3 almost of a millisecond, each of them. So we just used a tool to measure what's happening during the frame, and it showed us exactly what it is, exactly like these point lights. So now we know the what. What is slow. Next, because we know the what, we can try to figure out the why. Why are these lights slow? And I'm just going to try to find the lights. So I'm going to go in the outliner. Oh, there they are. Convenient. I'm going to click one of them. And okay, it's right over there. There's like 10 of them right next to the door. Looks fine, like how someone would use lights. I'm just going to start searching for the details panel for anything that looks weird. So we can see that they have cast shadows on. I don't think they need cast shadows because they're so small. And then the attenuation radius is 5,000. It's quite, I don't know what that means. Like, let's zoom out and see how big this light is. Okay. Each of those lights is lighting the entire level, even though we can only see a little dot there. So I'm going to fix it. I'm going to start by selecting all of these curse point lights, turning down the attenuation radius to about 100. You can see the outline now. And I'm going to turn off shadows. And the frame rate jumped straight up from 30 to 60. Single checkbox and one input field that are changed from 5,000 to 100. This is what I mean when I say lowest hanging fruit first. This was a small change that gave us a humongous amount of frame time back. And it didn't change at all what the game looks, because all of these lights were so small anyways. They were just misconfigured. Maybe the artist pulled them from some other part of the level and just adjusted the lighting intensity without doing anything else. But yeah, this shows you don't need to guess. You can just see the numbers, find it, estimate why is it slow, and then fix it. Now I'm going to run the profile GPU again, just to show you the difference of what it looks like. So I'm going to press Ctrl, Shift, and comma. And now if we look down the tree, you can see the duration of the whole frame is 12.96, which is under our 16 millisecond budget. So everything is now running at 60 frames per second. I'm going to go down into lights, direct lighting, and best lights. We have the directional light. We only always have one of those, so that's fine that it takes a lot of time because it's lighting our entire game. And I can't even find the cursed light anymore. They've just been batched together. So that's the second part I said about when you should stop profiling, when it doesn't show up on the profiler anymore. It doesn't, can't even see it. I think the first problem out of 4 has been fixed now. So I think we should go to the next problem. Tiny actor, huge hitch. This is like a tricky one. Anyone who's made a game, well, I'm not going to spoil it. Let's just go into it. So, wait, actually, before I go there, I want to have this doing this. Okay, beautiful. So QA comes to me, this hypothetical lead programmer, and says, Ari, something's wrong. And I'm like, oh, okay, well, I handled that other problem quite well. Give it to me. I think I can handle it. So we have this thing where in one part of the level, we'll start streaming in the next level in advance. And then we have another part that also has a little synchronous loading, meaning that it loads before the frame continues to the next one, of a tiny actor. And it usually always loads just fine. You can't even notice it. It's imperceivable. But sometimes there will be a huge hit depending on how you do this. And I'm like, well, that sounds like a pain in the butt to replicate. But they say, don't worry. We have a QA engineer who made a repro case for you. And I'm like, okay. They say, go into this level, and there's 2 actors there. Oh, wait. Before I continue, I don't want to show you this in the editor. I want to show you what it looks like when we have a package build. So I'm going to start by packaging the build, so you'll have like how the game would be running on Steam or something like that, but still in development build. So I'm going to just do platforms, build, and as you can see, package the project for Windows. And through the magic of pre-recorded presentations, I can now skip to packaging complete. What? Some of you might be asking, whoa, Ari, is Unreal Engine really that fast at packaging the project? And no, yes, let's say yes. Okay. So now we're done packaging. I'm going to open the folder where I saved the game to, and I'm going to make a shortcut to Unreal Insights from the Unreal Editor thing. So I can just start it from there instead of always having to open the editor. I'm also going to create a shortcut for the Lyra game executable, and I'm going to put in the trace overrides there, so that I kind of have better control of what I'm tracing. And then I'm going to just open the properties for the shortcut and start writing in dash trace. And in this video, I'm doing it super slow, so I'm just going to fast forward. So this is what I put in. So for CPU and loading profiling, you can use dash trace equals CPU, GPU, frame, log, bookmark. And then I'm also adding in file and load time because they said there's something to do with loading. And also, if you want to do memory profiling, that's just I just put it there also. You can use default in memory. I was told you should not usually put all of these together because each of them has a slight overhead. And you want to be as accurate as possible. So just make each trace session kind of looking for only what you really want to find. Also, you noticed here I used stat named events. You don't need to use it. I like to use it when I'm doing CPU profiling. It just activates a bit more CPU timing events so that you'll see a bit more what's happening. It's like it adds a tiny bit of overhead again, but it's fine because it's all relative anyways. So if something is really slow, it's going to be really slow even without this overhead. So you can see all the trace tools we have available on our Unreal Engine 5 documentation page that has called Unreal Insights Reference. The thing is, if you go to it from Google, they will usually still link to the old 4.26, and those trace tools are quite old. So if you do open the page, make sure you change the URL to say 5.0 instead of 4.26 or 4.27, or you can just use this QR code to go there directly. So now that I put this into the shortcut, I'm going to start first Unreal Insights. Just have it there, and then I'm going to start Lyra game. And you can see already that the trace session starts in the background. And I can even double click on it if I want to and look at it in real time as it is capturing data. So for now, I'm just going to minimize it, and I'm going to go to the repro case that the QA engineer made for me. So they have 2 volumes there they made. Okay. So first, I'm going to try to load the tiny actor that happens synchronously. And yeah, it was instant. Cool, how it's supposed to work. And then I go into load level, asynchronous. It says started loading map. And then in a few seconds, done loading map. That works perfectly. And I mark this as can't reproduce, fixed. Good job. But the QA engineer becomes a little bit angry at me and says, I told you you should do it in the opposite order. I'm like, fine. Okay, let's try that. Load level asynchronous and then immediately run over. Oh! There's like a 3-second hitch there. So this is actually part of the presentation where if you could guess this, I would give you an Unreal Engine t-shirt. So can anyone guess why this is happening? It's fine. It's fine. I will tell you anyways, but I will take this home with me. So don't worry. Don't worry also because it was a trick question. I would have given you the t-shirt, but I would have told you, you guessed the why instead of using the what first. So using my what, why, and how, we're first going to use the tools to figure out what exactly is happening. So I'm going to open the trace file. And so this is Unreal Insights. It's a rainbow of colors. We have a few tabs up there, timing insights, asset loading. You have the time of the game there. Here you have the frame times, and then you can turn on other tracks like graph track that shows you again how long each frame took. By default, it's docked and it takes a lot of space, so I like to right click and make it scrollable so it goes up with everything else. Also, because I have a hunch it's something to do with asset loading, I'm going to turn on the asset loading track, which shows you at which time every single asset is loading. Then I'm also going to turn on the frame track, which shows me what number of frame it is that is running at each time. And then here we have the CPU stack at each time of the application, and it's inversed. So the bottom here is like the first function that's running. That's usually the engine loop on the base, and then you can see which function that calls and which function that calls and stuff. Here we can see we started loading the asynchronous map, and here we can see the frame number 548. We can scroll wheel to zoom in a bit. And also here you can use shift and scroll to see the time. 3 seconds this one frame took here. This is one frame during like from 19 to 22 seconds. All the assets are being loaded here, and as soon as the level is done loading, it continues. So something is happening there that is waiting for the entire level to load. So let's just go down the stack and see what's happening. So it's kind of hard to see, so I'll just say it out loud. So we have here execute blueprint function, trigger cursed load tiny actor, that's calling load asset blocking, load object, load packets internal, and then it's calling a function that's called flush async loading. Flush async loading, why is it calling that, and why is it taking 2.5 seconds? This, now we know the what, now we can start asking the why. Why is this happening? Why? Why is my game so slow? Why is that slow? The good thing about Unreal Insights, and also about Unreal Engine in general, is that you have the source code for the whole of Unreal Engine. And Unreal Insights connects you to the source code. So you can even right-click on the functions, just say, go to source code, and then we'll get this. So here's the source code. We have a function called load packets internal, getting really technical now. And inside of that, we have here load packets asynchronously. And then what it does is that if it is doing something, it will call a function called flush async loading. And flush basically means load everything and wait while it's loading. And if it's waiting on the main thread, the game can't continue. It's just going to stop. So that's why we have that hitch. So that's very interesting. So apparently, we cannot call a synchronous loading function, something that makes the asset come immediately, while something is asynchronously loading in the background, because it will just suddenly make everything flush. And I don't know why, because it gets a request ID, and then it says like, here's the request ID, so it should in theory only like do that one. But the thing is, the Unreal Engine has its own thread for loading assets, and that one happens in serial, so not parallel. So it might maybe be loading all the assets before that until it loads that. Maybe. Anyways, we cannot have that hitch. So what I'm going to do is I'm going to just change this tiny actor loading to be synchronous to asynchronous. So I'm going to open the blueprint called trigger cursed load tiny actor, and there we can see load asset blocking. That's the why it's being slow. And I'm going to just call async load class asset and use that instead. And I'm going to put BP tiny actor there instead. And then I'm going to connect that up, but I'm going to connect the output pin not to the exit pin, but to the completed pin. So this one over here. And that means that this print string will only happen when the actor's actually done loading and not just when it has triggered the loading of it. Because then if you do the upper one, it will immediately call the string while it's still loading in the background. So I'm not going to show you what it looks like now because it basically doesn't hitch anymore. But the thing is, if you start loading the level first and then the tiny actor, it will still wait for the whole level to be done loading before it loads the tiny actor. So you're still waiting for it a little bit, but the game itself is running. There's no hitches. So, yeah, people sometimes ask, well, is there nothing we can do? Well, actually, there is this. I was going through Lyra and I noticed this class called fStreamable handle. And that one has this function called wait until complete. So you can do that while loading in a single asset. I was like, that's interesting. And then I'm going to read the comment over that function now. And it says, blocks until the requested assets have loaded, like the other function said. And then it says, this pushes the requested asset to the top of the priority list. Oh, sounds good. But does not flush all async loading. It's like they knew, like, oh, this function doesn't call flush async loading. And then the other function doesn't mention that. They're just like, well, this does something. So yeah, so you have this. So it says usually resulting in a faster completion than a load object call. So you can try this one if you want to load a small asset and you want it to be done faster than everything else, but without blocking. So okay, we can do that, and then let's just call this fixed for now. Okay, curse. Don't stop the video. Yeah, curse number 3 of 4. Foggy horror picture show. Anyone? That was the last pun. Only pun of the presentation, I promise. So QA comes to me and says, Ari, something's wrong. And I'm like, yeah, okay, I can do it. Yes, tell me what it is. I'll fix it. They go, as soon as you start a game and turn around, the frame rate crashes. And I'm like, okay, sounds easy enough. So I'm going to just go in and I'm going to turn on the stat FPS, turn around, and okay, this is really slow. That's like 8 frames per second. But I'm going to use the new console command I just showed you. Profile GPU and press enter. It hitches for like a second while it profiles the frame. And then it keeps running the game. What it did now was that it saved it, because this is not running in the editor. This is an executable that I showed you. And we don't get the pop-up that I showed you in the first cursed example. So it goes into the logs instead. So now we have to dig up the logs. So the logs are here under saved folder, logs, and there's the log file. And I've scrolled down already to where the profile capture was. You have to scroll a little bit. And the thing is, this happens in the order that they happened on the GPU, not sorted by how long they are. So you're going to have to go down a little bit until you see the percentage in the frame time show up. So here we can see translucency pass is taking 90% of the frame time. Translucency after death of field parallel is taking most of it. And then down here, we can see the culprit. 90% of the frame time, 135.96 milliseconds, is a material called M_cursed fog card particle. And the good thing about using Unreal's own profiling tools is that it gives you extra information that maybe other profiling tools wouldn't show you. So we have this particle material, but the thing is, Unreal shows you, and this is the particle system, Niagara system, cursed fog, that is using this material. Ah, fantastic. So now I can open this particle system called cursed fog and then check out the material to see exactly what's happening. So I'm going to do that. I'm going to... There's the cursed fog right there. I'm going to open it and I'm going to just start looking, because we know the what, I'm going to start looking for the why. Spawn rate is 50, not unusual for a particle system. Initialized particle has quite actually a big initial size, 500 times 800, and it's about 300 particles. For a particle system, it's not that much, but for some big particles, it is quite much. And this is the material. So we have a noise node there, and it's set to computational instead of a texture sample. Levels 10. Larger numbers cost more performance. Oh, there's a noise node, also levels 10, and then there's a Voronoi noise there that says quality 10, higher numbers are slower and higher quality. And then we have alpha, only 1% visible. So maybe we have some graphics people there because this will be, you would fix this no matter what game engine you'll be using. So can I just have some suggestions like, how can we just make this perform better? Just any suggestions? There are many right answers to this one. Yes, everyone who said lower the quality, keep your hand up. Let me see. You said, who also said lower quality? Ew. What else should we do? Lower the quality on the notes, yes. Plenty of other things to optimize. Yes, actually, do you want two? Because those are two really good answers. You stole two answers. What's that? Yes, we could just make the material more simple. Thank you, thank you, thank you. All of these good suggestions, all of them at work. So, by far, what I would start with was what you said. The alpha doesn't need to be 1% visible. That's barely visible. So someone is just like, oh, I want this to look like a real fog. There's actually a fog component in Unreal that you can use. So you don't need to like fake it like that by using cards on top of each other. And there's this thing called fill rate on all GPUs. That just means how many pixels the GPU can draw. And that is always limited. That's the first thing you'll hit a limit on. And that's usually when you draw multiple things over and over on the same area. And that's what you do with transparent graphics. So just do less of it, because this will put a PS5 or Xbox Series on its knees doing overriding the fill rate so much. So I'm going to put the alpha up, let's say 10% or even more. Also, it's kind of making these 3 nodes to make a fog that looks kind of like this. The thing is, none of this is dynamic. You can't really adjust the parameters. It's always going to look like this. So so instead of, calculating how this would look every single frame for every single pixel, just make this once in like GIMP or Photoshop, and then just make it a single texture sample instead. And also, like, if you do want to make this dynamic, you can just make all of these, because I wanted to make a really good example of something that takes a lot of time. And I don't know what takes a lot of time. Like, no one would realistically do something like this, but still, I just wanted to show on the profiler. So you can make all of these texture sample by default, which it does by default. You have to be really dumb to switch it over to computational and put up the level so much. But yeah, those are a few things. And then, no, that sounds good. So yeah, I don't have a video of it being fixed. Just imagine a fog that looks about the same, but it runs at 60 frames per second. Wow! Now we're at the last practical example. And now we're on a roll. We've been fixing everything using my what, why, and how. Let's say QA comes to me, Ari, something's wrong. And I'm like, what is it, my child? I will fix it. And they say, we have a memory leak. And I'm like, memory leak. Unreal Engine has tools to fix those things. Awesome. Okay, give it to me. How do I reproduce it? QA tells me, well, it's actually quite easy to reproduce. And I'm like, if something is easy to reproduce, it means it will get fixed. It's like, because you can find it every single time. It's just a matter of time. But they say, you start the game and you just don't do anything. I'm like, okay, perfect. And then you leave the game running for 3 days, and then it will crash. Only on consoles. And I'm just like, that doesn't sound fun, and I don't want to have this presentation run for 3 days while we wait for it to crash. But the thing about memory leaks is that if even the slightest amount of memory is leaking, we can find it. And nothing should be leaking in the game. So, because of this very awesome practical example, you're never going to have this, but for this presentation, let's say that you just hit a gold mine. I'm going to start the game, and I'm going to profile the memory over a few seconds, and then I'm just going to be done. And also, so I'm going to launch the game now with insights, and now I've changed them to be running the memory, and I'm going to run the garbage collector every frame, so we know there's for sure nothing that should be persisting between each frame. So I'm going to run type gc.collect garbage every frame, space 1. Now that's running. That's a good command to know. You should just write it down into your notes like I recommended you do. And now it's done. That's all I needed to do. In this perfect example where everything is like, dancing on roses. So I'm going to open the trace file, and here you can see the trace, the memory trace. Here we have the flags. You can see the garbage collection here running every single frame. If it's in your way, you can press that little white triangle up there, and it will hide the lines. But I want them shown for this example. And also, each one of these is the category of where the memory is being allocated. This is our old low-level memory system, but I'm just going to get rid of them because I'm going to use the new system, which is per stack allocation. So I'm going to select the time period here and then run a investigation on it. So here we have rule. Let's go with memory leaks rule. And I say, give me every single memory allocation that happened between A and B, and then C is when that allocation was released. So give me every single thing that happened here and then was never released. And then I run it and I say, I'm going to sort those memory allocations by the call stack. And then we have here on the top 22 megabytes leaked. And I'm going to right click on it and say expand critical path. And it will expand down the stack all the way to when the memory allocations are happening. So I'm going to toggle this away. So here we can see exactly where those memory allocations are coming from. So this is the stack again. And we can see that it's happening in a function called a cursed actor tick. You know, I don't think we need to go any further because I think I solved it. Every single memory leak had one thing in common. They were all in an actor called something cursed. Just change the naming conventions. Fixed. Just kidding. No, it's not that easy. So, but the thing is, because this is showing us the entire stack, we know that it's not happening in a sub-function of this. It's happening in the function itself. How many here are programmers, by the way? 1, 2, 3, 4. Okay. This is just for you, the next part. Sorry for the rest, but now you get to see a little bit into the world of memory leaks and programming and stuff. So I'm going to show you the code for cursed actor tick. This is an actual memory leak that happened during the development of Returnal. And I was the one in charge of finding it. And when I found it, I was like, this is so sneaky and clever, and what a fun memory leak that could definitely happen to someone. I have to put in a presentation someday. So I'm going to show you the code. I'm going to start explaining what the code is doing. Okay, we're almost done. This is the last thing. I'm going to explain what the code is doing. And if at any point you think you know why it's leaking, just shout it out. Here's the code. This is the header file. We have an array of structs, and the struct is called fstats capture. So these are value types. And then in the tick, it will call the super tick. It will add a new stats capture, stats captures.add, new stats capture, and put the time there. And then if we have more than 60 stat captures in the array, we will send those stat captures to the analytics server, and then we will empty that array. We're still emptying the array every time it's more than 60. So why is it leaking memory? Why is it leaking? What? I'm what? Yeah, but say it again. There's a new stats capture. Actually, you know what? You will get the t-shirt. You will get it. No comment. So there's something wrong going on there, definitely. It's like your hunch was right. Why is that new there? So in C++, this is how you should have written it. Because this is a value type. So you just call the constructor immediately. Whenever you do a new, you're creating a new thing of the object in memory. And then if you use the star, it's going to dereference that and create a copy and put that into the array while the original new is floating in memory. It's like, if you're coming from C#, you might write new there, and then you will try to compile it, and they'll say, you can't put a pointer type into value types. And you're like, what's that? And then you Google it. And Google will say how to convert object pointer into a value type. And they'll say, you just use the dereference operator there, the star, and then you put it there. But this is not how you do it in C++. When you have a value type, you just write the constructor immediately. So that was the last curse. I learned everything about Unreal Insights for this presentation from this presentation called Unreal Insights live from HQ inside Unreal on YouTube. So these are the two geniuses that made these tools, Jonat and Stefan. And you can see this presentation by following the QR code or just Googling that thing. And we are out of time, so if you want to reach out or if you thought, wow, these profiling tools are amazing, I want to use Unreal, but I want to know a little bit more about it, let's contact Ari. So there's my email and there's my Twitter and LinkedIn. I'm quite easy to contact. We have even time for questions.
We will make time for questions.
We'll make time for questions. Thank you so much, everyone. Thank you.